Okay, Newton's second law is stated in words that the acceleration is directly proportional to the resultant force. So if the resultant force doubles, the acceleration will double, and it's inversely proportional to the mass. So the heavier the object is, the harder it is to accelerate. But to be honest, you might have to quote them in an exam, but really, how we usually state Newton's second law is as RF equals ma. Sometimes you might see it written as F equals ma, but we use RF to remind you the key thing about this, which is it only works with the resultant force, okay? So for instance, let's say I have an object that is 10 kilograms, and I have a forwards force of 300 newtons and a backwards force of 100 newtons, and I'm asked to find out what the acceleration is, okay? What I would do is, first thing is work out the resultant force, which is 300 to the right minus the 100 to the left, which gives me a resultant force of 200 newtons. Only once I've done that can I use the equation. Okay, so I can't put in the 300 into the equation or the 100 into the equation. I can then do RF equals ma. So my 200 is equal to 10 times a, divide by 10, and it gives me that the acceleration will be 20, and acceleration is measured in meters per second squared. More difficultly, what they could ask is they could give you an object and say, okay, the forwards force is, let's say, 300 newtons. The backwards force is something we don't know. And this has a mass of 15 kilograms, and we're told the acceleration is equal to 10 meters per second squared in that direction. And we want to find out what that backwards force is, what the frictional force is. Well, if we've got a mass and an acceleration, you should be thinking I can use Newton's second law to work out the resultant force. So RF equals ma, RF equals 15 times 10, the resultant force is 150 newtons. Okay? But that's not our answer, because we need to find out what this backwards one is, and I've picked really bad numbers here because looking at that system, the resultant force is equal to the forwards force, 300, minus the backwards force, let's just call it R. Our resultant force is 150, which means R is equal to 300 minus 150, which is 150 newtons, okay? So while in this case our resultant force and this backwards force is the same, that won't always be the case, okay? So this equation will produce the resultant force. Quite often you then need to work back from all the forces that act on the object to work out which one of those forces are, okay? That's probably the most difficult question they can ask from this booklet. So I'll give you some questions on that now.